Hello. Good day, everyone. Welcome to Sir Phax
This meeting is being recorded.
Learning Channel. For today's video, pag-aaralan po natin kung paano nga ba nag-a-act ang light as a wave and as a particle. So, yung mga scientists po kasi natin, meron po silang kanikanyang theories, pag-aaral patungkol po sa light. For example, itong light po natin, pag pinatay ko to, yan, automatically, when you on the light, what will happen? Immediately, the light rays will goes through the spaces. Now, as the light rays goes to the space, the space, paano man yung available na space, how it acts, paano nga ba siya nag-a-act? Is it as a particle or as a wave? Tunghayan po natin yan dito sa video ito. Our learning target for this video is to cite experimental evidence showing that electrons can behave like waves. So, titingnan po natin ano nga ba yung mga evidences ni scientists na naniniwala na yung light is a wave or light is a particle. So, we will cite experimental evidence or evidences which shows that electrons can behave like waves. And then we will also differentiate dispersion, scattering, interference, and diffraction. Okay? So, how light acts as a wave and a particle. Paano nga ba nag-a-act yung light as a wave and a particle? Kung maririnig nyo po, mayroon pong nagpapanday sa kapitbahay po namin. Kanya-kanya po tayo ng trabaho. May trabaho ako, may trabaho din sila. Now, how light acts as a wave or as a particle? What do you think? Is light act as a wave or as a particle? Pero bago po natin alamin yan, what is light? Ano nga ba yung light? Alam lang po nating light yung ilaw. Diba? Yung ilaw. Yun lang yung alam po nating light. But light enables us to see objects. Without light, we cannot see definitely object. Definitely, we can't see objects. For instance, the sun. A light candle and electric bulb give out light. Tama naman. Electric bulb give out light. And they are called luminous bodies. Now, ano nga ba yung light? Sabi ni Newton, light is a particle. Sabi naman nila Maxwell, light is a wave. Sige, alamin natin paano nila pinatunayan yung kanilang mga theories. Yung kanilang mga evidences, ano ang kanilang mga ebidensya upang patunayan that light, na ang light ay wave or particle. Samantala, in the 17th century, two scientists, ito yung sinasabi ko sa inyo two scientists had different views about the nature of light. So, mayroong dalawang scientists na mayroon din silang kani-kanyang view about light. One of it is Isaac Newton. we know that Isaac Newton is a very known scientist, especially on his laws of motion. Pero meron din siyang idea about light. Ang sabi niya, light is a particle. Isaac Newton existed around 1643 to 1727. Pero may kumontra kay Isaac Newton. It was Christian Huygens. Si Christian Huygens nag-exist noong 1629 hanggang 1695. Kumbaga halos magkasabayan lang ang mga to. Mas bata si Isaac, pero mas nauna siyang nawala kaysa nag-exist. Nauna siyang nawala kaysa kay Christian Huygens. Sabi ni Christian Huygens, no, light is not particles but it is waves. So tingnan po natin, bakit nga ba iyon yung kanilang mga panuntunan about light. So sabi po ni Christian Huygens, as wave of particles, or later as we go along, since Isaac Newton in 16th century believed that light travels in a form of particles, na tinawag niya ito ngayong corpuscles. Samantala, si Christian Huygens, 16th century rin, inargue niya yung ideyang ito ni Isaac Newton. He argued that light might be some sort of wave motion, hindi particle but wave motion. Huygens came up with Huygens principles that explain the light is a wave travel through medium called ether. So, ganun po ipinaliwanag at gumawa pa siya ng mga principles, Huygens, na tinawag ng Huygens principles. Si Christian Huygens, he deduced the law of reflection and refraction and could explain double refraction to prove the theory of wave. Itong refraction kasi, idea po ito ni Isaac Newton. Pero, he deduced that by his law of reflection and refraction. I mean, by his double refraction, just to prove his theory that light is a wave. However, if light behaves as a wave, diffraction and interference should be seen using light. So, kung ang light behaves as a wave, so definitely dapat daw yung interference ng light, yung light interference, should be seen using light. Nakita nyo ba yung interference ng light? Nakakita na ba kayo ng interference of light? So, we do that since college. For us to see the interference, we do an experiment on a box, closed box, no light as well, in a dark room, tapos dark box din, and we use a pen light, and then the box, we put a small slit, and then, or very small slit, para lang magkaroon ng interferences. So, dapat daw, kung sinasabi ni Huygens na wave yung light, yung behavior ng light, so dapat makikita din yung interference ng light. Pero for Isaac Newton, naniniwala siya siyempre that wave is a particle. Since Huygens failed to provide any strong evidence to show that diffraction and interference of light occurred. So si Huygens, hindi niya masyadong napatunayan na mayroong diffraction at mayroong interference of light. And furthermore, Huygens could not explain why light has different colors. Hindi rin niya naipaliwanag. Bakit nga ba yung light may different colors? Ano ba yung different color ng light? The Roy G. Biv. Ano ba yung Roy G. Biv? The red, orange, yellow, blue, indigo, and violet. Yung rainbow colors. That's the different colors of light. He did not know that different colors of light have different wavelengths. So, hindi niya na-notice na yung mga different colors of light na yan, halimbawa, red, blue, green, may mga wavelengths yan. May mga kanya-kanyang wavelengths yan. And maybe, as we go along, pag-aaralan po natin, ano ba yung wavelength ng blue, ano ba yung wavelength ng red. Okay? And therefore, yung theory ni Isaac Newton, which is tinawag niyang Newton's particle theory, is acceptable since his strong evidence about particle nature of light. So, mas naging accepted yung idea ni Isaac Newton about wave is a particle dahil in a way na ipapaliwanag niya yung interferences of light, yung diffraction of light. Ipapaliwanag niya yun. And around 18th century, 1801, there was another scientist, Thomas Young. Gumawa siya ng double slit experiment. Ito po, I think, yung ginawa po namin experiment when we were college. The double slit experiment. Show the light diffracts and produce an interference pattern. So, itong double slit interference, ito yung sinasabi ko na mayroong box. Sa box, gumawa ng dalawang butas, tapos may flashlight. Flashlight mo, tapos makikita mo na mayroon dong interference of light. Ngayon, para ma-imagine ninyo, humanap kayo ng butas ng bubong ninyo. Butas dyan sa bubong nyo. Yung tumatago sa silid ng bahay. Yung magkadikit. Di ba yung rays ng sunlight sa butas is pa-diffract. At kung may magkadikit na butas, halimbawa butas 1, butas 2. May butas 1, butas 2. Yung magkadikit na yan, pag tinamaan niya ng light, so syempre paluwag spread out yung light rays. So magi-interfere ngayon yung light rays. So doon nakita ni Thomas Young yung interference pattern. And he therefore provide evidence. Si Thomas Young he was able to provide evidence that light has wave properties. Si Thomas Young lang pala yung makakapagpatunay nung sinimulan ni Christian Huygens. He showed that light ray interfere with each other. Such behavior could not be explained by particles. So ipakita niya by the double slit experiment, na ipakita niya yung pag-i-interfere ng light rays. Kagaya ng sinabi ko, pwede nyong gawin yan sa inyong mga bahay. Wait lang. Ito, halimbawa, ito yung box. Ito yung box. So, ang ginawa kasi namin itong box, let us assume na ito ay malaking box. Black box. Black box parang TV box. So, nilagyan namin ng butas dito, dalawa. Siyempre, dapat malaking box ito. Tapos, may flashlight. Doon sa loob, makikita nyo kung paano nag-interfere yung light rays. So, doon napatunayan ni Thomas Young na mayroon niyang interference of light waves. Siyempre, sa science, ang palaging meron naman dyan is the development, the improvement of research, scientific research. Sa around 18th century pa rin, si Maxwell naman developed a mathematical model of electromagnetism. He was able to show that these electromagnetic waves travel at the speed of light. So parang sumigunda ito si Maxwell kila Huygens Thomas Young na yung wave nagtra-travel as a form of light. Therefore, he asserted that light was a form of high-frequency electromagnetic wave. Kalahin mo yun? Sinuportahan pa niya yung pag-aaral ni Christian Huygens. Na sabi niya na yung light is yung wave is travels at a speed of light. Ano ba yung speed of light? 3 times 10 to the power of 8 meters per second squared. So, kumbaga parang nasa 300 million meters per second. Kaya pag nagbukas ka ng switch sa bahay nyo, kung ano yung space na available dyan sa room, automatically, nandun agad yung light rays. Diba? Hindi mo mahahabol. Walang slow-mo na light rays. Kasi kung may slow-mo na light rays, pag nagbukas ka ng ilaw, unti-unting yung ilaw unti-unting tumatama sa wall, matakot ka. Ibig sabihin, may kababalaghan dyan sa room mo. Okay? Now, 19th century. Ito ngayon yung another improvement. Si Max Planck naman. He was able to explain the spectrum of black body radiator by assuming that light energy is quantized. The quantum of light energy was later named as photon. So, si Max Planck, inexplain din niya yung spectrum of light. Na yung light, naka-quantize yan. At tinawag niya yung quantized light as photon. Few years later, around 1905, Albert Einstein used Planck's idea to explain photoelectric effect to support the particle behavior that light and came out with quantum theory. Okay? So, parang itong si Albert Einstein, ginamit niya yung particle nga ba? Or wave? Ang light behavior. Now, sige, tingnan po natin itong mga ideas nila. Isaac Newton, for him, light, he proposed a particle theory of light. Christian Huygens, he proposed wave theory of light. Si Thomas Young, he in favor wave theory of light. James Clerk Maxwell, he in favor wave theory of light. Max Planck, he in favor particle theory of light. Albert Einstein, he also in favor particle theory of light. And Louis de Broglie, he in favor wave-particle duality. So, feeling safe tong si Louis de Broglie. Ang light daw is a wave and a particle. May duality. May dual citizenship. Okay. Ito yung double slit experiment. Sino yung gumawa ng double slit experiment? Sino? Max Planck? Sino? Sino yung gumawa ng double slit experiment? It was Thomas Young. Okay? Thomas Young. So, ito yung ginawa ni Thomas Young. A gun spray bullet towards target and the resulting pattern is map of likelihood of a bullet landing at each point. Now, the quantum paradox. Electrons like bullets strike the target one at a time. So, as shown on the figure or on the illustration here. Okay, nakikita nyo ba yung illustration dito? Ayan. Panoorin nyo kung paano yung mga bullet nag-strike. Yet, like waves, they create an interference. So, you will see here, itong mga bullets, nagkakaroon sila ng interference. If each electron passes individually through one slit, with what does it interfere? Though each electron arrives at the target at a single place and time, it seems that it has passed through, or it has passed through. Thus, the electron is understood in terms of wave-particle duality or quantum mechanics theory. So, ano na ngayon? Dahil parang nahati na sila. Mag-boxing na lang kaya sila. So, light is a wave or a particle? What do you think? On a microscopic scale, we can treat a large number of photons as a wave. When dealing with subatomic phenomenon, we are often dealing with single photon or few. Kaya lumabas nga yung kay de Broglie, di ba? Louis de Broglie. Yung wave-particle duality. Na for him, as a conclusion, scientists have observed the light energy can behave either like a wave as it moves through space, or it can behave like a discrete particles with a discrete amount of energy that can be absorbed and emitted. So, ibig sabihin, light can travel as a wave as it moves through a space. Or it can also travel or behave as a discrete particles with a discrete amount of energy that can be absorbed by and emitted. When light interacts with atoms and molecules, they act like a stream of energy called photons or quanta. So, napansin nyo ba, yung sunlight, kapag tanghaling tapat, yung bubong nyo na bakal, yero, kapag tumatama yan, have you noticed na parang pag sinilip mo ng ganyan, yung bubong nyo, parang may kumukulo? And definitely, yan po yung tinatawag na photon or quanta. Na parang nagra-radiate. Na-observe nyo ba yan? So, try to observe. Huwag ka namang umakyat sa bubong nyo, baka mahulog ka. Masisi pa. Sabi kasi ni Sir Phax, i-observe ko daw yun eh. Tapos mahulog ka. Ako pa yung sinisi. Huwag ganun. Okay? Impossible lang naman. Kung pwede mo ma-observe, why not? Pero kung hindi kaya, huwag ka nang umakyat sa bubong nyo para lang i-observe yun. Therefore, there are two theories of light which explain the nature of light. So, wave theory and particle theory. Wave theory, it explains that light behaves as a wave. Particle theory, syempre, light behaves as a particle or photon. Ayan, tingnan nyo yung nandito sa diagram. Okay? Ayan po yung mga taong yan. Tingnan nyo yung mga pagmumukha nila. Sila po yung nagpagulo sa mga isip natin. Nananahimik yung ilaw eh, pinag-aralan pa nila. Particle daw, wave daw. Eh, nasa yan kung anong paniniwala. Sino yung paniniwalaan mo sa kanila? Christian Huygens on his reflection and refraction, Thomas Young on his diffraction and interference, diba? Dahil dun sa kanyang double slit experiment, or si James Maxwell sa kanyang electromagnetism, that light or wave travel as a light or electromagnetic light waves daw, sabi ni James Maxwell. Wave as a nature of light. Siyempre, pag pinag-usapan po natin yung waves, may mga theories din po yan. which explains that the wave as a nature of light. In wave theory, light is considered as an electromagnetic wave. So sa wave theory, this electromagnetic wave consists of two components, which the electric field and the magnetic field. Naalala ko po ito, yung dalawang wave na magkasama na color red and blue. So magkasabay silang nagmo-move. Yung isa, electric field, ang isa, magnetic field, which oscillate. Ano ba yung oscillate? Oscillation. Parang nag-oscillate. And perpendicular to each other, as well as to the direction of wave propagation, as shown here. Ayan. Kita mo yan? Ganyan po yung electromagnetic wave. Ito po yung magnetic wave or field, at ito namang red one is the electric field. According to the wave theory proposed by Christian Huygens, light is considered to be emitted as a series of wave or wavefronts in all directions. A wave has wavelength, frequency, and velocity. So as shown also in this figure. Ayan, nandyan sa figure na yan. Therefore, following properties can be defined for light by considering wave nature. So ito po yung mga properties ng wave. The wavelength is the length that one cycle or distance between two crests. Di ba yung wave na kaganyan siya? Yung one crest to another crest is one wavelength. Frequency, as one of the property of light, is the cycle of wave repeats in 1 second. The number of wavelengths or the frequency, the number of one cycle per second, which is measured in hertz, unit hertz. And then another property is velocity, or the distance covered by the wave in 1 second. So the velocity. Another property is period, the duration of the cycle, reciprocal of the frequency, mathematically expressed as T, or the period, is equal to 1 over the frequency. Kaya nga reciprocal frequency. And another property of light is the wave number, the number of waves spread in a length of a meter. It is reciprocal of wavelength. Wavelength is equal to 1 over velocity is 1 over the wavelength. And then amplitude, the distance from the midline to the peak wave, or the measure of intensity of brightness or light radiation. So these are the properties of light waves. Siyempre, kung may properties, meron din characteristics. Ano yung mga characteristic ng light waves? The velocity of light waves is not constant. Yung velocity ng light waves, hindi daw constant. It depends on type of medium the wave travels through. Okay, pwede. Velocity over speed of light wave in a vacuum is denoted by C, or the speed of light constant, 3 times 10 to the power of 8 meters per second. Ayan, nandiyan po yan. The relationship among frequency, light, velocity, and wavelength is expressed as mathematically as lambda, ayan, yung parang y na nakabaliktad, is equal to C over F. Ano yung C? Speed of light constant na 3 times 10 to the power of 8 meters per second. Ano ulit yung F? Frequency, the number of waves or vibrations. From the equation of wavelength, it can be seen that wavelength is inversely proportional to the frequency. High frequency means short wavelength. Low frequency, it means long wavelength. Now, light wave have different colors of dispersion, and it depends on the frequency or wavelength. The different frequency or wavelength of a wave will give different color of light as shown here. Ayan. Light wave could diffract or interfere as shown below. The propagation of light through space can be described in terms of traveling wave motion. And the light wave moves energy without moving a mass from one place to another at a speed independent of its intensity. And the light waves can move three different polarization: linear, circular, and elliptical polarization. Ayan po yan. The linear, this is the linear. Ayan. Ito yung circular, at ito naman yung elliptical. Ayan, as shown here on our screen. So, ito ulit yung mga tao who supported particle theory. Isaac Newton on his reflection and reflection phenomena of colors, Max Planck on his blackbody radiator, Albert Einstein on his photoelectric effect or quantum theory of atom. So, Isaac Newton proposed that light consists of stream of small particles because it travels in a straight line and great speed and is reflected from mirror on a predictable way. So, kaya nga daw, pag nanalamin ka, kung ano yung itsura mo, yun na yun. Kaya pag, wag kang mag-ambisyon. Tanggapin mo na lang kung ano yung meron. Para pag nanalamin ka, hindi ka na magugulat. Sabi na Isaac Newton yan eh. Sabi niya, yung light nagtra-travel on a straight line at a great speed. Kaya, nagre-reflect yung light sa mirror with the same speed, with the same particles. Kaya kung ano yung finokus mo dyan sa mirror, yun na talaga yun. Hindi na yun magbabago. Sabi ni Isaac Newton. Ako nag-instrumento lang ako dito. Wala akong sinabing masama. Yung kasi yung ipinahihiwatig ni Isaac Newton. Newton observed that the reflection of light from a mirror resembles the rebound of steel ball from steel plate. So parang pag bounce ka daw ng steel ball sa steel plate, ganun din daw yung reflection ng light. Parang ito yung light, tatama dito, ito yung mirror, tatama, magre-reflect yan doon, with an equal angle. Na parang pag nag-bounce ka daw ng ball, steel ball sa isang steel plate, ganun yung magiging result ng pagbabounce. Kung ano yung angle ng ball, ganun din yung angle ng pag-bounce. Ganun din daw yung light. Okay? This theory, particle theory, explained that the particle photon as nature of light. From quantum perspective, light consists of particle called photon. Ano nga ba yung photon? Photon is a very tiny little particles that has energy and movement or momentum, but it has no mass or electrical charge. According to Albert Einstein, photon is considered as discrete packet of energy or quantum. Okay, take note for that. Photon is a very small particle that could see by eyes. Couldn't see by eyes. So, hindi pala ito nakikita. Actually, ito po yung ina-absorb ni solar panel, yung mga photons. Ito po yung ina-absorb ni solar panel kapag nagre-recharge yung solar panel natin. Yung may mga solar panel pala, hindi natin. Yung school po natin, merong solar panel sa bubong to minimize the electric bill, electric charge. So, photon is a pocket energy, sabi ni Albert Einstein, or wave packet. So, ano yung characteristic ng photon? Una, sabi ni Albert Einstein, no mass and no electrical charge. Walang mass, walang electrical charge. Photon carries electromagnetic energy and momentum. Meron siyang electromagnetic energy at meron ding momentum, as well as intrinsic angular momentum or associated with its polarization properties. Photon travels at a speed of light in vacuum, equivalent to the speed of light. C is equals to 3 times 10 to the power of 8 meters per second. According to quantum theory, a photon has an energy of HF. Ayan, yung nasa equation po natin. HF or ano yung H? May constant value po yung H, Planck constant, 6.2 ayan, nakalagay po dyan sa screen po natin, 6.625 times 10 to the power of negative 34 joules per second. Yung F is frequency, which is also equal to H, C, or Planck's constant times the speed of light, 3 times 10 to the power of 8 meters per second, over its wavelength. Ayan po, yung mga ibig sabihin ng mga variables na given po dyan. H, C, and lambda, wavelength. A photon also carry momentum P, and the momentum is related to the energy by P is equal to energy over the speed of light, or C, equals to Planck's constant over the wavelength. Unit measure, joules second per meter. Okay? Hindi ko na ibibigay sa inyo yan. The energy of a light photon is proportional to the frequency and inversely proportional to the wavelength. The higher the frequency or lower the wavelength, the higher the energy or the photon. Higher frequency, photon gains more energy. Lower frequency, photons gains less energy. For example, blue ray has more energy than red ray because blue ray has higher frequency than the shorter wavelength of red ray. Now, photon can interact with other particles such as electrons, protons, and neutrons. Kasi particle nga siya kaya for them, for Albert Einstein, Isaac Newton, pwede siyang makapag-interact ng electrons, protons, and neutrons. Ano ulit yung mga to? The positive charge, the negative charge, and the neutral charge of an atom. When photons bump into another atoms, some of their energy can get the electrons in those atoms moving faster than they were before. So, pwede pala po siya makapag-energize sa mga particles na to. That's why you get hot seating in the sun. Kaya daw ka pala naiinitan kapag may flag ceremony. Because of this process na na-energize ni photon si electrons, protons, and neutrons. A photoelectric experiment by Einstein shows that a very energetic photons or blue light has a very high frequency and could knock the electrons out from metal surface to produce a current as shown here. Ayan. Okay? So, ito yung light photons, ito yung electrons ejected from the surface. Ayan. Tinatawag na photoelectric effect. The increasing of frequency will increase the energy of proton. Therefore, photons blue light could eject the electrons compared to red light because the blue light has higher frequency. Okay? The range of frequencies of electromagnetic radiation is called electromagnetic spectrum as shown here. Ayan, nasa screen po natin. Siyempre, may tinatawag na visible light. Visible ba yung light? Pag sinabing visible light is a small part of an energy range of electromagnetic waves. The whole range is called electromagnetic spectrum and the visible light is in the middle of it. Alright. Ayan. Electromagnetic spectrum. Okay. Alright. That is the electromagnetic spectrum through the process of dispersion of light by a glass prism. You will see there the different colors of light. Decreasing wavelength, increasing frequency, increasing energy based on the arrow here. Light is a special kind of electromagnetic energy with a wavelength range from 380 nanometer to 740 nanometer of visible light. And this electromagnetic energy consists two components, which electric field and magnetic field, yung kanina, which oscillate perpendicular to each other. And this electromagnetic radiation are produced by vibration of charged particles called photon. Okay? So, ano yung characteristics ng light? It travels on a straight line. Kaya nga sabi ni Isaac Newton, nagba-bounce off sa isang surface, plane surface, at the same angle. As shown here on the illustration, light travels at a high speed, equivalent to 3 times 10 to the power of 8 meters per second squared. Kaya pag binuksan mo yung switch ng ilaw mo, automatically bounce agad yung kanyang light ray sa wall, sa surface na hanging. Light travels in a vacuum at constant speed. However, when light travels in a non-vacuum or medium such as air, glass, water, and speed of light will decrease. Kasi syempre naapektuhan yan. Naapektuhan syempre. Kaya nga, kapag depende kasi yan sa, sa surface din. Light consists of different types of colors. Paulit-ulit na natin yan. Ayan. Light has different phenomena when it interacts with another object, such as it passes through, it reflects, scattering, absorption, and refraction, based on the different figures there. So, kapag pass through, syempre, tumagos. Tumagos. The rays of light can pass through. Sa Tagalog, yung rays ng light, tumagos. Reflection, it refers to the rays of light can be reflected off the object or yung nag-bounce off, nag-bounce back. Scattering, the rays of light can be scattered off. So, depende kapag usually nag-i-scattered po yan kapag rough yung surface. Absorption, the rays of light can be absorbed by the object. Refraction, the rays of light can be refracted through an object. Yung pencil nilagay sa water, sa glass of water, makikita mo doon parang malaki yung pencil na nandun sa loob ng glass with water kaysa yung nakalabas. So that's the effect of refraction of light. Ano nga ba yung mga sources of light? Siyempre, alam naman natin, I think ito, the natural sources, sun, star, radio star, lightning. Ano yung mga man-made naman? Ayan, yung ring light mo, bulb, fluorescent light, solar light, all material with temperature above absolute zero emit electromagnetic radiation. For example, atoms and molecules which has their own characteristic set spectral lines. Okay? Alright. Atom equilibrium, hindi na natin kasama yan. Ito yung black body radiation ni Max Planck. Hindi naman nakasama natin yan. At least na ipaliwanag na natin. Bakit nasabi nila na yung light nagta-travel as a wave, yung light nagta-travel sa particle. Siguro humanda na rin kayo dahil baka yan yung ibigay kong activity sa inyo. Ayan po yung mga unit of light. Luminance, luminous intensity, luminance, L. And that's all for now. Hopefully nakatulong po itong ating video lessons. Ito po ay nakapaloob sa medyo late na ito. Week 4 and week 5 pinagsama ko na po kasi isang content lang siya eh. Pagsasamahin ko rin po yung week 6 and week 7 at lastly week 8 na. So within this week din po yan ay ilalabas ko rin po yung week 6 and week 7. I think ito magbibigay ko sa inyo ng isang activity lang for week 4 and 5 sa ating leap sa ating module. At kung bago pa at hindi ka pa nakapag-subscribe sa channel ni Sir Phax, please support Sir Phax Learning Channel by clicking the subscription button at yung notification bell. Piliin mo dun yung all para updated ka sa mga susunod ko pong video lessons. For now, mga video lessons po muna tayo. Hanggat hindi ko pa natatapos gawa ng mga video lessons, yung aking mga lessons, syempre. Kasi pag natapos ko ng gawan yan, definitely, wala na akong ibang, natapos ko ng gawa ng content yung mga lessons ko. So, mag-isip na naman si Sir Phax ng panibagong mga content. Pero sana, patuloy nyo pong suportahan yung learning channel ni Sir Phax at sana nakakatulong po ito sa inyo. At kung meron po kayong mga kilalang senior high school who are taking this subject, physical science right now, kapag first semester sa senior high school, Earth and Life Science, pwede nyo pong i-share ang mga video lessons po ni Sir Phax. Marami pong salamat. Happy learning everyone.